Okay guys, so in this one we're going to be doing a mass to mole calculation. Okay, so in this one we're going to start with a given mass and we're going to be changing it into moles of another substance. So first of all, let's give you the generic for that. So that should be the mass of A. Okay. It's going to be setting up our conversion factor, and then on here we're going to have the molar mass of A on the bottom. And that is going to be over 1 mole of A. And then we're going to have our mole ratio, and that's going to be mole ratio of B over mole of A. And that is going to allow us, and those two cancel and those two cancel, then our answer is going to now be in moles of B. Okay? And so when we start with this, we're going to give you an arbitrary number, so we're going to say that we're beginning with 87.67 grams of iron oxide, Fe2O3. And we would like to figure out, this is a product, we'd like to figure out how much product of moles of SO2 are created along with it. So to do that, we need to first figure out the molar mass of this. Okay, so we need to use the periodic table and figure out what these are made out of. So this is going to be made out of iron and oxygen. Okay. And so using the periodic table, first let's write down how many there are. So we have 2 irons and 3 oxygens. Okay. The 2 irons are going to be multiplied by their atomic masses from the periodic table. So when you look that up, that should be 55.85. And for oxygen, that should be 15.99. Okay, and so when you multiply those two, I'm going to take a second, pause it, and figure out what that adds up to. But this should be 111.70, and this should be 47.97. Okay, and now that's not the actual molar mass. We need to add these two up. Okay, so that's going to be a total of 159.67, and that's going to be grams per mole. Okay, so that is going to be what we're going to use over here. And now for mole ratio, our B to A, we need to use from the equation up here. Okay, so we're using these two on this side. So our A is going to be our 2 moles, okay, of Fe2O3, iron oxide, is equal to 4 moles of sulfur dioxide. Okay, so that's the ratio we're going to use. So now we have this, we have this. We can now work it into the equation. So let's write out what we begin with. Our mass of A should be 87.67 grams of iron oxide. Okay. Now, setting up our conversion factor, our first step, we do like it says here, 1 mole of A is going to be, and in this case, I shouldn't put A, I should put the actual formula, that's Fe2O3, and that's going to be equal to this number right here, 159.67 grams. Okay. Now, again, you can choose to stop here and get a number, but that's going to end up messing you up with rounding, so we're going to set it up as if this was one long equation. Now, but if you do end up stopping and figuring out an answer for just this, and this is again grams of Fe2O3, and that cancels. So if you do get an answer for this, you end up getting roughly 0.55 moles of Fe2O3. But that's not the answer we want. We want the answer in moles of sulfur dioxide. So that's why we're going to do the second step with the mole ratio from the equation. And if you look right here, we already wrote that down. So we need to write down our moles of B, the thing we're trying to change into first, because you put what you want on top and what you're trying to get rid of on the bottom. So here, this should now be this ratio of 4 moles of SO2 over 2 moles of iron oxide, Fe2O3. And what that allows us to do is now we're able to cancel out those moles and those moles. And if you look at what's left, we've crossed everything out except for moles of SO2. So at this point, you can do the math. 87.67 times 1 divided by 159.67. That answer will be multiplied by 4 and then divided by 2. So I'll give you a second if you want to pause that and see if you come up with the right answer. But the correct answer I got after doing those calculations was 1.09 moles of SO2. Okay? And so that's another, it's just a simple two-step problem, but the trick is knowing how to set it up and making sure you calculate this molar mass. And again, we're always, for every single one of these, using a mole ratio. So make sure you keep track of where we got these. The mole ratio always comes from the equation given after it's balanced. Okay?